Welcome to The Explainer. Today, we are going on a journey right through the very fabric of the cosmos. We're exploring the mind of Albert Einstein, the genius who literally redefined space, time, and reality. Before he became this legendary cultural icon with the wild white hair, he was really just a person looking at the universe with this immense, unyielding sense of childlike wonder. So let's step into his shoes and see how he fundamentally changed our entire understanding of the universe. But first, imagine this. What if time doesn't tick at the same speed for everyone? It feels completely impossible, right? We all experience time as this constant, unstoppable metronome just ticking away in the background of our lives. But what if that's all just an illusion? What if your reality, your space, and your time depend entirely on how fast you're moving? By challenging these super basic perceptions of reality, Einstein pulls us directly into the deepest mysteries of the cosmos. Chapter 1, The Spark of Curiosity. So our hero's journey doesn't actually begin in some massive, high-tech laboratory. It starts in Munich, Germany, with a 5-year-old boy lying sick in bed. To cheer him up, his father brought him a simple pocket compass. And young Albert? He was completely mesmerized. No matter which way he turned the little device, the needle always pointed north. The realization that some invisible force could move that needle without even touching it, well, it sparked a moment of pure magic that would ignite a lifelong quest. And that compass sparked a lifelong obsession with understanding the hidden forces of nature. Now, contrary to the popular myth you might have heard, Einstein was actually an excellent student in math and physics, but he absolutely chafed under the strict authoritarian teaching style of his schools. He was a free thinker stuck in a very rigid system. So after graduating, he actually struggled to find a teaching post and ended up settling into a quiet, pretty undemanding job as a third-class patent clerk in Bern, Switzerland. But ironically, it was exactly this quiet desk job that gave his brilliant mind the freedom it needed to just wander. Which brings us to Chapter 2, 1905. Scientists often call this his annus mirabilis, or the miracle year. And it is honestly hard to even comprehend. Here you have this 26-year-old patent examiner working a totally mundane day job, evaluating technical documents. Yet in his spare time, he's quietly writing papers that are about to completely rewrite the rules of the universe. Okay, let's dive into this, because it is wild. In just one single year, Einstein published 4 groundbreaking papers, back to back. Just look at the sheer rapid-fire magnitude of this output. In March, he tackled the photoelectric effect. May, Brownian motion. June, the special theory of relativity. And in September, mass-energy equivalence. Look, any single one of these papers would have been enough to cement a major scientific career. Einstein dropped all 4 in a matter of months. Let's break down the core takeaway of each really quickly, because together they completely demolished classical physics. First, he proposed that light isn't just a continuous wave, but actually comes in little discrete packets of energy called photons. Second, he mathematically explained the random jittering of particles in a fluid, which provided the definitive proof that atoms and molecules actually exist. Third, special relativity demolished the idea of absolute time and space, proving they are totally relative to the observer. And fourth, he showed that mass and energy are entirely interchangeable. And that fourth paper gave us E equals mc squared. I really want to give this iconic equation the breathing room it deserves. The absolute game changer here is that c squared factor, the speed of light squared. Because the speed of light is already a massive number, when you square it, it becomes astronomical. This reveals a profound cosmic truth. Even the tiniest speck of mass contains a mind-boggling amount of bound-up energy. It proves that mass and energy are literally just 2 forms of the exact same thing. Chapter 3, The Fabric of Space-Time. So, after 1905, the scientific world really starts waking up to his genius. But Einstein? He wasn't even close to finished. He spent the next decade stretching his ideas even further. By 1915, he had expanded his ideas to include gravity, producing the general theory of relativity. And this is where our understanding of the cosmos takes a sweeping, monumental shift. Now, what's really interesting here is how it changed our fundamental view of reality. For centuries, Sir Isaac Newton taught us that gravity was this invisible pulling force acting instantly between objects. But Einstein completely shattered that paradigm. He argued that gravity isn't a pulling force at all. Instead, imagine the universe as a literal fabric, the fabric of space-time. Mass and energy actually curve and bow this fabric, so picture a heavy bowling ball resting on a trampoline. What we feel as gravity is simply objects sliding along the dips and curves created by those heavy masses. It's actually wonderfully accessible when you go step by step. Step 1, you have a mass, like a star or a planet sitting in space. Step 2, this mass naturally warps and curves the space-time fabric right around it. Step 3, other objects, like comets or light beams, are just trying to travel in a straight line, but they're forced to follow the contours of this newly curved environment. That geometric curve, that literally is gravity. And this new framework made some absolutely awe-inspiring predictions that Newton's theories just couldn't explain. Einstein predicted gravitational lensing, meaning massive objects would actually bend starlight as it passed by. He predicted black holes, where the space-time curve is so incredibly extreme that not even light can escape it. He even predicted gravitational waves, actual ripples in space-time itself. And in 1919, a British astronomer named Arthur Eddington observed the bending of starlight around the sun during a solar eclipse, exactly as Einstein predicted. Bam! That single observation made him world-famous overnight. Chapter 4, The Real-World Impact. Now, it's really easy to look at things like black holes and bent starlight and think, well, that's a beautiful story, but it's all highly theoretical. But actually, Einstein's deeply abstract ideas fundamentally shape our modern world. They directly impact the technology we rely on every single day. And this brilliantly illustrates how mapping the cosmos translates straight to the smartphone in your pocket. Think about it. The GPS satellite system you use to navigate, it constantly relies on corrections derived from relativity just to keep you on the right road. His prediction of stimulated emission, that's the literal foundation of all lasers and fiber optics. E equals mc squared is the underlying principle of nuclear energy, and his work on the photoelectric effect is the foundational science behind solar cells and the digital camera you use every day. So, that brings us to 1921. This was a massive, pivotal year, because it was the year Einstein finally won the Nobel Prize in Physics. But here is a fascinating little detail. He didn't win it for the theory of relativity. No way! He won it specifically for his discovery of the law of the photoelectric effect. That was the work from his miracle year proving light acts as a particle. It was just so irrefutable and so foundational to the brand new field of quantum mechanics that the Nobel Committee simply couldn't ignore it. Chapter 5, A Lasting Cosmic Legacy. Beyond the chalkboard, Einstein's later life was deeply, deeply driven by his humanitarian values. In 1933, he was forced to flee the rise of the Nazi Party in Germany, and he emigrated to the U.S., joining the Institute for Advanced Study in Princeton. He used his immense global platform to fiercely champion pacifism and civil rights, famously joining the NAACP and calling racism America's worst disease. On the science side, he spent his last 3 decades on one ultimate elusive quest, a unified field theory that would tie everything together. Now, he never actually completed that unified field theory before his death in 1955. But his legacy? It is virtually unparalleled. He completely transformed the nature of theoretical physics, proving the absolute power of deep intuition and mathematical elegance. He stands not just as a brilliant physicist, but as a passionate humanist, a philosopher, and a moral voice who fundamentally shaped how we think about our place in the cosmos. He once famously said, "Imagination is more important than knowledge." And when we look back at his life, from the little 5-year-old totally fascinated by a compass to the quiet patent clerk dreaming about riding light beams, we really see that a childlike imagination was his truest tool. Knowledge tells us what is, but imagination? Imagination tells us what could be. It was this boundless imagination that let him see right past the rigid illusions of everyday life to fundamentally redefine reality. So, what does this all mean for us? Einstein unraveled the very fabric of space and time simply by asking the right questions and daring to imagine the answers. So, I want to pass that wonder on to you. What hidden forces of the universe are still out there, quietly waiting for the next curious mind to discover them? Keep asking questions, keep imagining, and we'll see you in the next explainer.